Hello, this is Brother Cromer again. And in the last video, we discussed center and shape of a distribution. Here's a review of that. Here's two examples of using histograms. It's this shape, which is a right skew distribution, with the mean, because we have a right skew distribution, being slightly larger than the median. And this here, it's hard to tell what this one is, especially with these outliers over here. But we look at the median and the mean, and we find that they're really close. So you could argue that it's either bell-shaped or a right skew distribution. So we talked about, we can look at shapes and we can look at the center of a distribution, but how do we measure spread? Well, how we measure spread is by what's called the variance and the standard deviation, but primarily what we look at is the standard deviation. Now here's a formula. Now this formula here is for the variance, and then we take the square root of the variance to get the standard deviation. Now basically instead of looking at this formula, what I like to do is how do we calculate a standard deviation? Looking at it in terms of maybe perhaps looking at a table. So what I'd like to do is I like to pull up the ages of a children of a teacher in the math department. And here are the ages, 13, 15, 17, 19, and 21. These are the observations, okay? And so what we like to do is we want to figure what the standard deviation is of these children, okay? So what I'd like to, so first of all, the very first step you have to do is that you have to get the mean. And so looking at this, even by eyeballing this, you could tell that the mean is about 17, okay? Because it's symmetrical. But all you have to do is sum them up, these values up, and divide it by the number of observations, which is 5. So then what we do is that we take each of those observations and subtract the mean, this mean here, from those observations. So we take 13 minus 17 to get negative 4. We take 15 minus 17 to get negative 2. And we get 17 minus 17, which is 0, 19 minus 17, which is 2, and 21 minus 17, which is 4. So that's the next step, is getting this column right here. X bar is your sample, is your mean, okay? Then the next step is to get the squared deviation. So we take these deviations and square them. So negative 4 squared is 16, negative 2 squared is 4, 0 squared is 0, 2 squared is 4, and 4 squared is 16. Okay, so basically what we did here, if we go back to the formula, so we did this top part right here, this formula. We took all the observations, subtract the mean from them, and squared them, and that's what we did here. Okay, now the variance, but we're not done with getting the variance, because to get the variance, we have to take that top, the numerator, and divide it by the denominator, which is n minus 1. So it's the number of observations minus 1. So we take 40 divided by 4. So where we got 40 is we sum these up, 16, 4, 4, 16 plus a 0. And we get 40, and we divide it by the number of observations, which is 4, and that is equal to 10, and that is our variance, okay? And now we take the 10 and we take the square root of 10 to get the standard deviation. And if we use that on a calculator or whatever, we would get a standard deviation of 3.16. So that's how we calculate the standard deviation by hand, okay? Now, what I'd like to do, so if we wanted to get this in SPSS, what we can do here, in fact, we've done it before. I'll just use the credit data here, the number of credits students have taken. And if you run analyze descriptive statistics and explore, and then you run that with whatever data, credit or whatever else you want to do, you can get the variance and the standard deviation right here, and you can calculate those two numbers. It's fairly straightforward, okay? So now what I'd like to do is that briefly explain what the uses are of the standard deviation, okay? Now, it determines more or less the average distance from the mean from all the data points. So the smaller the standard deviation, then those points will be closer to the mean, okay? So we also want to compare different distributions. We're capable of finding percentages of data that approximately fall between certain points of what's called the normal or bell curve. We can determine possible outliers. Now, those who've taken Math 108 can see the empirical rule, where if we know the standard deviation, about 68% of all data fall within one standard deviation, 95 fall within 2, and 99.7 fall within 3 standard deviations of the mean. Also, we can determine outliers. Any data outside of 2 standard deviations from the mean would be considered an outlier, and any data 3 standard deviations from the mean would also be considered an outlier. And that concludes this dealing with standard deviations. Next, we'll talk about box plots.